So hello guys. So today I will show you how to determine the degree of freedom, okay? And also we will not discuss on that also, but I will show you how to formulate the joint load factor, joint load vector and the reaction vector. So in my previous video, I discussed about the concept of degree of freedom. So now we will have a specific example, okay? So consider this truss. Pin, pin, and you have roller, then surrounded by member, then of course you have some loads. So here, how can we determine the degree of freedom? So as I mentioned in my previous video, you can determine either by examining the figure, or you can do it by, of course, the empirical formula. So for example here, what will happen if this truss with a given load? Of course, we can say that this will move, okay? Maybe it will move like this. Okay, so here, how many degrees of freedom? So we can say that how many degree of freedom is actually the number of translation. So here, uh, there will be translation here 1. Okay, there will be translation here 2. Then here, this is roller, it will move somewhere here, so there will be a movement here 3. Then from this point, it will go to another point, so there will be translation 4. Then you can say here 5, then 6, then 7, then there will be translation 8 and 9. So how many translation or how many degree of freedom? It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this is pin, there will be no translation. Okay? But here, it will move either at horizontal and vertical movement or translation. Here also it will go up. But the translation along X, it will not move along X. It will move only along Y because this is roller. It will move up and down, up and down. Okay? But if you want to determine the degree of freedom using the formula, you can have also the number of degree of freedom is equal to the number of joint minus number of reaction. So how many joints we have? 1, 2, 3, 4, 5, 6, 7. Okay, I'll repeat. 1, 2, 3, 4, 5, 6, 7. So, number of joint is actually 7. So, how many reactions? It will be 1, 2, 3, 4, 5. Okay? 5. So, now, the number degree of freedom will be 2 times 7 minus 5. It will be 9 degrees of freedom. Okay? So, uh, to determine this is degree of freedom. Okay? How about if we want to determine the joint load factor? Okay? The joint load factor is assumed based on the given load. Okay? So for example here, we will have only the load at here. We have also load somewhere here, here, and here. Okay? So, meaning the the joint load vector is based on the translation. Okay? What is the meaning? The meaning is the reason why at this point there is translation along x is because of the load of 20 kilonewton at 20 kips. The same is true at this point. The reason why this one is moving is because of the joint load 3. Okay? So in reality, if I will draw that one, we can represent by point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, this, can you see what I mentioned here? The joint load vector is based on the translation. So, there are 9 translation, 9 degree of freedom. There will be 9 joint load also. Okay? And also, after you are done with joint load, you can now proceed with the reaction vector. So, here, always start with the horizontal. It will be 10. Wait. Can be 11. So, to represent that this is reaction, you can put dash. 12. Then 13. Then we have here 14. Okay, so now, to proceed with the joint load vector P, it will be 1, 2. The joint load vector is also based on the actual load. So, for example, here at point 1, I mean at P1, you have 20. So, you have 20. At this joint, what will be the value of P2? It will be 0 because there is no actual load. It's only 20. You proceed with this one. What is the load here? None. So 0. You proceed with number 4. What is the load here? You have 20. Then 0. Next 6. 0. Then we have here 35. The direction is downward, negative 35. Then at this point it will be 10 and negative 20. So this is now the joint load factor. So now if we want to determine the reaction vector, reaction will be, of course it's not yet determined, so you can represent by simply putting reaction at 10, reaction at 11, reaction at 12, reaction at 13, and reaction at 14. Take note as I mentioned 9 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. So how many? You can represent also, let's say this is 0.1, 0.2, 0.3, 0.4, 5, 6, and 7. So, of course, the number of the joint load is not it's not always equal to the joint factor. 20, 0, 0, 20, 0, 0, negative. So here I will repeat for the joint load vector at point 1, at point 3, check, it's only 20 and 0. At this point, 0 and 0. 0 and 0. And you proceed here. For 5 is 20 and 0. Here is 0, negative 35. Here is 10 and negative 20. Again, sorry, I made a mistake a while ago. So here, what we can say is the number of the degree of freedom is actually the same number of the joint load. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this 9 joint load is the one that causes this 9 degrees of freedom of translation. Okay? Can we have more examples? So let's have another example. Is it clear? Is it clear? So let's have another example. Can we check in the book if we have some examples here? Yeah. Let's say problem 3.1. I'm using matrix structural analysis by kasi mali So let's solve 3.1. So, same. What is the problem here? We want to determine the number of degree of freedom. This is question mark. The second one is the joint load factor, joint load vector, and also the reaction vector. Okay? We want to determine these three. So, again, if you do not want to determine the if you do not want to use the formula, or you want to check it by seeing the diagram, what we can predict here is it will go like this. Okay, I'm sure. Okay, sorry, this is mistake. This is mistake. Okay, so here what we can say is there will be, oops, mistake again. Maybe it will wait. So there will be, let's say, there will be displacement 1 here, and there will be displacement 2. And the reason why there is displacement 1 is because of the joint load 1 and because of the joint load 2. Okay? So now, based on the figure that we have, we can conclude now that the number of degree of freedom will be 2. Okay? So if you do not believe on it, we can check. The number degree of freedom will be 2 times the number of joint minus number of reaction. What is the number of joint? 1, 2, and 3. 3. Number of reaction? It will be 1, 2, 3, 4. 4. So, using the formula, 2 times number of joint is 3, minus number of reaction 4 is, this is second degree. Okay? How about the joint load? Okay? Here you have, okay, let's redraw. One, 2. This is reaction 3, and say P1 and P2. Then reaction 4, reaction 5, and reaction 6. Now the joint load vector will be P is equal to, here check the actual load. You have always proceed with the horizontal reaction. 12, then 20, downward, negative 20. Okay? For the reaction vector, it will be reaction R3, R4, R5, and R6. Later on, if you determine the reaction, you can now proceed with this. Okay? So that's it for the degree of freedom, for the joint load, and for the reaction vector. So I will have another video for coordinate transformation, global and local coordinate system. Okay, so wait for another video. Thank you for watching and listening.